Today, our topic is barbiturates, and discovering how tiny changes in their chemical structure can have big effects on their action. Ever wondered why some barbiturates knock you out in seconds while others take their time? Let's break it down. At the heart of every barbiturate is this little guy, barbituric acid. But what makes each barbiturate unique is what we attach to the 5 position of this molecule. These attachments, or substituents, are like the accessories that define their personality. Think of these substituents as branches on a tree. The more branching, the more lipophilic, or fat-loving, the molecule becomes. This changes everything about how the drug works in your body. First up, let's talk about lipophilicity. Increased branching makes a barbiturate more lipophilic. This means it can slip through the blood-brain barrier faster, giving you that quick, knockout punch. But here's the catch. These drugs also leave the brain quickly, moving into fat stores in your body, which shortens their duration of action. Take thiopental, for example. With its highly branched structure, it's super lipophilic. It's used in anesthesia to induce unconsciousness almost immediately. But just as quickly as it puts you under, it's out of your system, making it ideal for short procedures. Now, let's switch gears to less branching. When a barbiturate has less branching, it's less lipophilic. It takes longer to cross the blood-brain barrier, so the onset of action is slower. But it sticks around longer in the brain because it's not as quickly redistributed to fat tissues. Phenobarbital is a perfect example. It has simpler, less branched substituents, making it less lipophilic. It takes longer to start working, but once it does, it lasts longer, which is why it's used for long-term seizure control. So, to sum it up, the more branching at the 5 position of a barbiturate, the faster it acts and the shorter its duration of action. Less branching means a slower onset but a longer duration. Understanding this balance helps scientists tailor these drugs for specific medical uses. Remember, thiopental for rapid short-term anesthesia and phenobarbital for sustained seizure control. It's all in the branches. Thanks for joining us on this molecular journey. If you enjoyed this video and want to learn more about how tiny tweaks in chemistry make a big difference in medicine, hit that subscribe button and give us a thumbs up.